Assalamu alaikum students. Today we are going to discuss how to balance a chemical equation or an ionic equation by ion-electron method. So what to do first? First, you will see that this is the equation given us and medium is shown there. Chromium hydroxide CrOH thrice, IU3 is iodate ion, CrO4 2 minus is chromate 6 ion, and iodide. So first we will see what are the oxidation state. So for chromium hydroxide, chromium is +3. As you can see that overall charge on this chromium hydroxide is 0. So we have written 0. OH has -1 charge. As there are 3 OH groups, so 3 multiplied by -1, it remains -3. So Cr -3 is equal to 0. So the overall charge of the charge on the chromium in chromium hydroxide is +3. Similarly, we can calculate it for chromatine. So chromatine has overall charge -2 that you can see here. So on the right side of sign of is equal to, we have written -2. As there are 4 oxygen atom and oxygen has -2 charge with all the elements except fluorine. So it is multiplied by 4. So 4 multiplied by 2 is equal to -8. So on mathematical operations, after this, we got it that chromium is +6. So in this way, you can see here the chromium on left hand side is +3, while on right hand side it is +6. Now see the charge on iodide and iodate. So for iodate, we have to calculate. Iodate is having -1 charge. So on the right side of is equal to sign, we have written -1. And as there were 3 oxygen, so multiplied by -2. Again, the concept is that oxygen has -2 oxidation state with all the elements except fluorine. So it is 3 multiplied by -2. It equals to -6. So I -6 is equal to -1. When you shift it on the right hand side, it becomes positive, and the final answer for iodate, iodine in iodate is +5. And on right side, it has negative charge, -1 charge. So when a single atom has whatever the charge it has, it is the same for its oxidation state. So it is -1, whether you write it here or not. Now see, as the reaction is in basic medium, so in basic medium, we have 2 methods. Method 1 follows the overall acidic, it is the same as we balance the chemical equation in acidic medium. So what we are doing here, you can see. So in method 1, when we consider it as acidic medium, then finally we will convert it into basic medium. So in this method, just like uh, just like the previous examples that we have done in other videos, that we split the ionic equation into 2 half equation. One is the oxidation one. As you can see here, it is going from 3 plus to 6 plus. So this is the oxidation reaction because oxidation number is being increased. And here it is going from +5 to -1. So here oxidation number is decreasing. So this is the reduction equation. Now the second step is the balancing of oxygen and hydrogen atoms. And before balancing of oxygen and hydrogen atom, we should note that other atoms other than oxygen and hydrogen, they are balanced. You can see one chromium is on left side and one chromium is on right side. So it means chromium is already balanced. Iodine is also balanced on both the side. So it means we don't need to balance the other elements except oxygen and hydrogen. So now see, in case of this equation, as we are doing it with as the method of the acidic medium. So in acidic medium, what we do that as many oxygen are lesser on any side, right hand side or left hand side, we add water. So see, there are 4 oxygen atoms and there are 3 oxygen atoms only. So for balancing the oxygen, what we do, we add 1 water molecule on left hand side. So now on right and left, on both the side, oxygen atoms are same. They becomes 4. 3 for chromium hydroxide, 1 in water. So it becomes 4. But what happens? How many hydrogen are there? There are 3 hydrogen and in chromium hydroxide and 2 hydrogen in water molecule. So there are 5 hydrogen atoms. So for balancing hydrogen atom on right hand side, we write 5 hydrogen ions. 5 protons have been written here. So in this way, we have balanced the oxygen and hydrogen in oxidation equation. Then in the next equation, iodine is same, but there are 3 oxygen on left hand side and no oxygen on right hand side. So we have added 3 water molecules on right hand side in this equation. And for balancing hydrogen, see how many hydrogen are here? 3 multiplied by 2, it means 6 hydrogen are there. So we have added 6 hydrogen ions on the other side. So in this way, we have balanced in the single step both oxygen and hydrogen. You don't need to show these steps individually. Now, charge balance. If you see the reduction equation, in the reduction equation, this is reduction equation, and the above one is the oxidation equation, as we have already mentioned in the first step. So in reduction equation means in the second one, iodine, there are +5 charge on left hand side. Why it is +5? Because you can see that it is -1 and it is +6. So -1 and +6, it means the total net charge is +5. So there is +5 charge. So on the right hand side, there should be the same charge. So what to do? We have only -1 charge on right hand side. So how can we manage it? So both the side charge must be same. Whether it should be +5 on the right hand side or there should be -1 on the left hand side. So how can we do this? If we add 6 electrons, if we add 6 electrons on left hand side, see what we have done. We have added 6 electrons on left hand side, and now see the charge has been balanced. See, see what we have done. We have added 6 electrons here. I'm writing it again. So we have added 6 electrons on left hand side. So now see the total charge on left hand side. Now the total charge on left hand side, you can check it that -6, then -1, then +6. So the net charge is now -1 because it has been cancelled out. So -1 is remaining. And on right hand side, water has no charge, but iodide has -1 charge. So we have balanced the charge in this equation. Now see on the in oxidation equation, the total charge on right hand side is -3 +5 and -2. Oh, I have already balanced, so I don't need to show it. It was this equation. Huh? So the total charge here is +3 because -2 and +5. And on the left hand side, there is no charge. Zero charge is there. So for balancing the charge, we add 3 electrons here. So on adding 3 electrons, now you can see that -3 +5 -2. So -3 and -2 is equal to -5, -5 +5 cancelled out. So the equation has been balanced according as per the charge. So charge is also balanced. So in this way, we have seen that charge and elect charge is also balanced in both the equations. So after balancing the charge, and remember that we balance the charge by adding electrons on either side. We have to balance the charge in the given equations. But what happens, what's wrong here is that number of electrons are different in both the equations. So in the next step, we are going to balance the electrons. So the first equation is the oxidation equation. It was having 3 electrons that you can see here. It was having 3 electrons, and here it has 6 electrons. So for balancing the number of electrons in both the equations, because we have to cancel them in the next step. So we just multiply oxidation equation by 2. So by multiplying oxidation equation by 2, we have multiplied it by 2. So see what happens. 2 multiply by 1, because if nothing is there, so it means 1 mole is there, so it becomes 2. It was also 1, so it becomes 2. It was also 1, it becomes 2. And it was +5, it was 5, so it becomes 10 hydrogen ions. And 3 electrons were there, so it becomes 6 electrons. Okay, so you can do this by using pencil, but using your ink pen or the pointer, you will write it again. So you will write both the equations again. Okay, so in this step, you have balanced the electrons. After balancing electrons, we will add both of the equations. So first rewrite the equations in the next step. It is better for you. And then cancel out the electrons. 6 electrons are here, so we have cancelled out these electrons. Okay. And there were also 6 electrons. I think I should have mentioned both the equation in one go. So let me do it. Let me do it. So both the equations should be rewritten. So we have rewritten the equation here, and I'm just managing it in the space. So now these two equations can be added. So see, how can we add this equation? 6 electrons on the right hand side and 6 electrons on the left hand side. So these have been cancelled out. So what are remaining here? 2 Cr OH thrice. So 2 moles of chromium hydroxide plus iodate is only here. So in the next we write iodate ion. Then we will see water. Water is on both the side. So as you can see, there are two water molecules. So there on the left hand side, there would be no water. And on right hand side, one water is remaining. Okay, that we will write here in the equation. And hydrogen ions, there are 6 hydrogen ions on left hand side, while 10 hydrogen ions on the right hand side. So after cancellation, there would be only 4 hydrogen ions. So it means nothing should be written on the left hand side except this 2 moles of chromium hydroxide and 1 mole of iodate. So then draw the arrow. This chromate is 1, so write it as it is, CrO4 2 minus, and iodide is only 1, so write it again, iodide. And how many hydrogen ions are remaining here? 4 hydrogen ions and 1 water molecule. So in this way, we have balanced this equation, and you can remove this pencil work. Okay. So in this way, we have balanced the equation according to acidic medium. But remember that as hydrogen ions are there, and we must note that as the equation is in basic medium, so we have to convert it in basic medium. So if there are 4 hydrogen ions on right hand side, so we must add 4 hydroxide ion, but we can't do this on only one side. So we add 4 hydrogen ions on both the sides when we are going to convert this equation into the basic medium. So this is the 6th step, not the first. It is 6th step. Okay. So add 4 hydroxide ions on both the side. See, we have added 4 hydroxide ion both the sides, for here and for here. See, 4 hydroxide ion here and 4 hydroxide ion here. So what happens when these 4 hydroxide ions combine with 4 hydrogen ions? So they form 4 water molecules, and 1 water molecule was already there. So collectively there are 5 water molecules, while the remaining part of the right hand side is as it is. While on left hand side, there is nothing to neutralize this OH. So these four OH ions, 4 hydroxide ions, would remain as it is. So in this way, we have balanced this equation. And finally, you may show it by making a rectangle around it, or you may leave it as it is. But better to write here balanced. Balanced. So this is the one way to balance the ionic equation by ion-electron method, using considering it as acidic medium, and finally we can convert it into basic medium. So this is the one of the way to balance a basic medium, an equation in basic medium. But the method that is written in the books, that we balance the basic equation in another way. So we can write it as method 2. But remember that in method 2, the first two steps are same. In the first step, we find the oxidation number. So the oxidation number you can see here, there is 3 plus on chromium hydroxide, 5 plus on iodine of iodine, and plus 6 for chromatine, and minus 1, it is already written here. So after calculating the oxidation state, again we do the same thing, that we have divided the equation into half ionic equations. One is the oxidation one and another is the reduction equation. And we have already mentioned that here chromium is 3 plus. It is going from plus 3 to plus 6. It means there is loss of electrons. So this is oxidation. And it was already 5 plus, but here it is minus 1. So it means it has gained some electrons. How many electrons must be gained? Plus 5 becomes neutral. So 6 electrons it has gained. So it becomes reduced to iodide. Now, when we are doing the second method, so in this method, oxygen and hydrogen are balanced in another way. What to do? If you see the original equations, there are 4 oxygen on right hand side and 3 oxygen on left hand side. So what we do first, we do it step by step. First, we will add only one hydroxide on the left hand side to balance the oxygen. So we have balanced the oxygen. Now on both the side, oxygen is 4. Now see, on both the side, oxygen is 4. So if oxygen atom are the same, it's okay. But what to do with hydroxide ions? Hydrogen of the hydroxide and hydrogen of the chromium hydroxide. So there are 4 hydrogen atoms. So if we are adding hydroxide on left hand side for balancing the oxygen, then hydrogen is balanced by adding hydrogen ions on the right hand side. So what if I add 4 hydrogen ions here? Oh, sorry, we add water. So how many water should be there? There should be 2 water molecules. But remember that by adding 2 water here, oxygen becomes unbalanced again. देखिए यहाँ पर क्या था, 3 ऑक्सीजन और 1 ऑक्सीजन, 4 ऑक्सीजन, तो ये तो हमने बैलेंस कर दिया था. That we have already balanced, but for balancing the hydrogen, oxygen becomes unbalanced again. So what to do? Definitely, if oxygen is balanced, oxygen was balanced in this way, and by adding water, hydrogen has been balanced, but there is the okay. So I was telling you that in balancing oxygen, hydrogen becomes unbalanced, and when we are balancing hydrogen, so oxygen become unbalanced. But we remember that hydrogen is balanced right now, so we try to keep it balanced. So if I uh, add 2 more, as there is 1, so hydrogen are 3 and okay. So what if I add 2 OH is here? See, plus it was 2H2O. Okay. अब यहाँ पे हम क्या कर सकते हैं? If there are 2 plus 4 oxygen and there is only 3, so what if I add 2 here? So okay, oxygen is again balanced because 4 plus 2 is 6 and here 3 plus 2, no, there should be 3. So in this way, oxygen is balanced again, but hydrogen becomes unbalanced. 3 plus 3 is equal to 6 hydrogen. So if there are 6 hydrogen atoms, so we must add one more hydrogen here, one more water here. So it becomes 3 water molecules. 3 water means 3 twos are 6 hydrogens. Yes, hydrogen is balanced. 6 hydrogen are on left hand side as well. 3 in this chromium hydroxide, 3 in this hydroxide ions. But see the oxygen again. 4 plus 3, 7. And here 3 plus 3, 6. So again, we have a problem of balancing oxygen. And we know that if we are going to balance oxygen, hydrogen becomes unbalanced. So we try it again by adding 2 more water molecules, 2 more hydroxide ion here. So what if we add 2 more water hydroxide here? So by adding 2 more hydroxide, and there are 5 plus 3, 8 oxygen atoms. So there should be 8 oxygen atom as well on right hand side. So it becomes 4 plus 4, 8 oxygen, and there are also 8 oxygen atoms. And how many hydrogen are here? 4 twos are 8, and here 5 hydrogen plus 3 hydrogen, 5, 3, 8. So in this way, we have balanced the oxygen and hydrogen by adding hydroxide and water on either side. Now, in the reduction equation, you can see there are 3 iodate, 3 oxygen in iodate ion. So first we add 3 hydroxide on the right hand side to balance the oxygen. And for balancing the hydrogen, we can add water molecules here. So how many water molecules should be here? Definitely, it cannot be 3 water molecule, because 3 water molecule means 3 twos are 6. So the other way that we can balance it, balance the hydrogen, if there are 3, so there must be double of this. So if double of this is 6 hydroxide, so there should be 3 water molecules. So hydrogen has become balanced, but see how many oxygen are there. 6 oxygen on right hand side and 6 oxygen on left hand side. So in this way, we have balanced both oxygen and hydrogen. Remember that this is the hit and trial method in step 2. And it is somehow difficult as compared to the balancing of oxygen and hydrogen in acidic equation. So that's why I always prefer that you balance the equation by acidic medium, then finally you convert the acidic medium into the basic equation. Now the charge balancing has the same rule, just like previous, but see what is here. There is -5 total charge on left hand side, because chromium hydroxide has no charge, but there are 5 hydroxides, so -5 is on left hand side. And on right hand side, there was initially there was no electron. We will add it. So there is -2. So -2 and -5. So making it -5 on right hand side, we add 3 electrons here. So it becomes -5 overall charge on right hand side. So right hand side is also -5, left hand side is also -5. So we have balanced the charge of the equation. In the next, in reduction equation, you can see on the left hand side there is -1, and right hand side there is -7. See, -1 plus -6. So -1 and -6 become -7, and there is only -1. So we are to add 6 electrons on left hand side. Now overall charge is -1 on both the side. There is also -1, -7, sorry, not -1. So in this way, electron are balanced in these both the half equations. Now finally, We balance the electron by multiplying oxidation equation by 2. So it becomes 2 chromium hydroxide plus 2 multiplied by 5 hydroxide ions, 2 chromatines, 4 multiplied by 2 8 water molecules, and 2 multiplied by 3 6 electrons. And no need to multiply reduction equation, it is as it is written. And finally we have added both of them, and you can see here when we have added both of these, I will show it to you that there is 2 chromium hydroxide we have written as it is, then 1 iodate we have written as it is. Electrons has been cancelled out because electrons are same on both the side, right and left. But see how many hydroxide are there. There are 10 hydroxide and there are 6 hydroxide. So there becomes 4 hydroxide on left hand side. But see water, there are 3 water molecule on left hand side, but 8 water molecules on right hand side. So the remaining water are 5 water molecules on right hand side. So in the right hand side there is 2 chromatines and 1 iodide. Hydroxide ion has been cancelled. Only 5 water molecules are there. So in this way equation is balanced. Now see, now compare both of these method. In both the method, final equation is same. This is balanced equation and this is also balanced equation. But the step that is different is balancing of oxygen and hydrogen. This step is different. And you can see it is difficult to balance in case of hydroxide. Why it is difficult? Because in acidic equation, we just add hydrogen ions to balance the hydrogen. But here we are to add water molecule to balance the hydrogen, while oxygen are balanced by hydroxide. So there is no 1:1 ratio. That's why it is difficult. Hydrogen has unit charge, so it can be balanced easily. It can be written as single atom, single ion, but water always has 2 hydrogen atoms. So that's why it is slightly difficult way. So anyway, we have balanced the this equation by both the methods. It's up to you. Whatever you can use and you will get the full marks. तो स्टूडेंट्स आपको मैं बता दूं कि आप कोई सी भी तरीके से इक्वेशन को बैलेंस कर लीजिए, आपको पूरे मार्क्स मिलेंगे। हाँ, अगर आपने कोई गलती कर दी है तो फिर डेफिनेटली जिन स्टेप्स में गलती होगी वहां पे मार्क्स डिडक्ट हो जाएंगे। और ये भी ध्यान में रखिएगा कि आपके पास अब एग्जामिनेशन टिप क्या है आपके लिए। एग्जामिनेशन टिप्स ये हैं कि आपको ऐसा नहीं हो सकता कि दोनों ही 3 इक्वेशंस आमतौर पे दी जाती हैं और 3 में से या तो कोई एक इक्वेशन करना होगी या 2 इक्वेशंस करना होंगी, और 3 में से 2 इक्वेशन ज्यादातर एसिडिक मीडियम में दी जाती है। तो मैं तो आपको ये मशवरा दूंगा कि आप हमेशा एसिडिक मीडियम वाली इक्वेशंस को सिलेक्ट कर लीजिए। अगर आपको ये डाउट है कि जनाब मैंने बेसिक मीडियम वाली इक्वेशन को एसिडिक मीडियम से बैलेंस कर दिया तो मार्क्स डिडक्ट हो जाए, अव्वल तो होंगे नहीं, लेकिन अगर ये डाउट्स हैं भी आपके पास तो ठीक है, आप दोनों एसिडिक मीडियम वाली इक्वेशन कर लीजिएगा। और इन केस कि आपको एसिडिक मीडियम वाली इक्वेशन समझ में नहीं आ रही है बेसिक मीडियम वाली, तो ट्रस्ट मी कि आप अगर बेसिक मीडियम वाली इक्वेशन को भी शुरू में एसिडिक मीडियम से सॉल्व करते हुए चलें और लास्ट में उसको बेसिक मीडियम में कन्वर्ट कर दीजिए बाय कैंसिलेशन ऑफ द हाइड्रोजन आइंस। हमारी रिक्वायरमेंट बैलेंस्ड केमिकल इक्वेशन है, हमारी रिक्वायरमेंट आपका वो मेथड नहीं है, क्योंकि हमने आपसे ये कहीं नहीं एम्फेसाइज किया, कहीं नहीं आपको रिस्ट्रिक्शन दी कि आप बेसिक मीडियम से ही बैलेंस करें। अगर ऐसा कोई क्वेश्चन आ जाता है, क्वेश्चन में अगर ये आपको इंस्ट्रक्शन दे दी जाती है तो फिर आपको ऐसा लाजमी करना होगा, लेकिन आमतौर पर ऐसा नहीं किया जाता है। सो यू कैन डू इट इन ईदर वे, इट्स अप टू यू। अल्लाह हाफिज, इंशाल्लाह नेक्स्ट वीडियो में बाद में मिलेंगे।